using the circumcenter of a triangle to find segment lengths. So we would need to know what a circumcenter meant. And I know that sounds very close to another word. We say circumcenter. So first it says consider triangle XYZ in the figure below. The perpendicular bisectors of the sides of its sides are TS, US, and VS. They meet at a single point S. In other words, S is the circumcenter of XYZ. So we can come down here and we see S is this center point. It doesn't mean that it's the center of the triangle. It just means specifically where the perpendicular bisectors meet. So a perpendicular bisector is, and here I'll put this in a different color here. So they say it's TS, US, and VS. So those were the perpendicular bisector. So we can see that they're perpendicular with this mark, because that means 90 degrees. Bisector also gives us a bit more information. Bisector means that it cuts this in half. Each segment is cut in half, and I'm doing different tick marks because it cuts this line in half, so these two pieces must be the same. This red line cuts this side in half, so these two pieces are the same. And then again, this red line cuts the bottom in half, so these two pieces must be the same. But it doesn't mean that, say, XT is the same as XV. That's not the relationship. It just cuts the side in half. That's all it does. But that's quite a bit of information that we've already been given just by hearing perpendicular bisector. And then it goes through and it starts to give us more information here. So it tells us that VS is 66, and here I'm going to change my color. So VS is 66, and then it tells us that YZ, so this side, is 82. And then VS, which is this distance here, is 110. So we are given quite a bit of information there. Now, what do we do with that information? First, let's look at the explanation. If you haven't been reading the explanations or writing notes, you should definitely start writing notes. That's one of the biggest reasons that students are struggling through some of this, is that they're not reading the notes. They're just clicking start, and then they get to the next page and have no clue what to do. Slow down, read the definitions, and make sure you understand, what does this circumcenter theorem even say? What does this point matter in the problem? It does matter. It gives you a special relationship. So you need to slow down and make sure you read it. So if you didn't know what perpendicular bisector was, it defines it real quick. Perpendicular bisector of a segment is perpendicular to the segment and bisects the segment. To bisect the segment means to intersect the midpoint of the segment or cut it in half. Okay. So if you didn't know what that meant, it gives you the definition right there. All right, so the circumcenter theorem says the perpendicular bisectors of the sides of a triangle intersect at a single point. This point is equidistant from the vertices of the triangle and is called the circumcenter. So this point is the same distance from this point to this vertex, y. I can go back to the center here to this point, and it's the same distance to z, and it's the same distance to x. So if I know that this is 110, I know they're all 110. I'm just going to write that one sideways because I didn't feel like moving my whole board sideways there. So that point is equidistant from the vertices. So we've done a couple other ones. We did one that was centroid, and that had to do with being equidistant from these perpendicular bisectors. But they weren't perpendicular bisectors that we were focused on. It was actually medians we were focused on. Angle bisectors that we were focused on that one. So it just depends on which definitions they're giving you and what they tell you that is happening. Since it's a perpendicular bisector, we know that we're talking about the circumcenter, which is the same distance from each vertex. So now when we go through and we want to find XS, well, we already found it. It's 110. Then we want to find UZ. So let's see. if we want to find UZ and we know that the whole thing is 82, well, I already went around and marked the bisector part of this. We know that this is the midpoint. So this is half and this is half. So I'm just going to take 82. I'm going to divide by 2 and I get 41. So UZ has to be, I'm just going to go like this and be a little lazy here. UZ has to be 41. All right, and the last piece they're looking for is YV. So YV. So this one is going to take a little bit more remembering, I guess is how I should put it. So this is a right triangle. So if we know it's a right triangle because it has a right angle in it, and I know that this side is 66 and this side is 110, and I'm going to rewrite it out here like this. So I have 66, 110, and I have a right triangle. Well, whenever I have a right triangle and two sides, I can find the missing side with something called Pythagorean Theorem. And most students remember it as soon as I start writing a squared plus b squared equals c squared. They can usually finish it before as soon as I write a squared, usually students can finish this. So it's, for some reason, Pythagorean Theorem, the name throws them off, but the actual formula usually is remembered. So this is what we want to use. And anytime you have a right triangle, so you need a right angle, with one missing side, you can use this theorem. So A and B are the sides that make up this right angle. So it doesn't matter which one's A and which one's B. So let's go ahead and call this one B for whatever reason. C has to be across from the right angle. So C is always the biggest side, but you can't always tell that right away because we don't know what B is. So you always go across from the right angle, and that is C. So I have 66 because I'm deciding that's A, plus B squared equals 110 squared. And they actually did give us the calculator on this one because I think they knew we were going to be using some of these amounts. All right, so move this in a way where I haven't written somewhere. All right, so we have 110 squared. And they don't give us a square in this one, but they do give us this symbol. So I can click on it, and then it gives me this box. So I can type a 2. So instead of just giving me X with a 2, which a lot of the time they do have on this calculator, for whatever reason they don't have it this time. So I know this amount is 12,100. We still have B squared, so now I need to know what is 66 squared. And we get 4,356. We're going to subtract this from both sides, 4,356, because I want this B squared all by itself. So if I subtract a number from itself, it cancels. I bring down B squared equals, I'm going to go back to my calculator here. So I have 1,200, nope, I forgot the 1. 12,100 minus 4,356. All right, so I get 7,744. And then I want to take the square root. So I'm going to write this really quick. So I have 7,744, but I don't want to know what B squared is. So whenever you end up with a variable squared, you want to take the square root of it. Remember, this means B times B. That's how we got B squared. And the square root of something means that I can take out one of those things. So the square root of 12,100 is 110. Yeah, it's 110. So you have 110 times 110. That's how we got 12,100. So the square root is just going backwards and saying, well, what number did you multiply 2 times in order to get that? So remember, it's not 110 times 2. It's 110 times 110. So the same thing here. I have B times B, which gets me B squared. So I just want to know what number gets me the square root. As long as this is highlighted, I can click on this and it'll put it in there correctly. If it wasn't highlighted, it would actually put it in after the number. All right, so the answer is 88. And I'm going to show you really quick what I mean by that. So if I had this in here like this, and then I clicked this, it puts it in after. So the only reason it put it in correctly is because it was highlighted, and then it was like it understood, okay, you want the square root of what's highlighted. So then it'll work. So if you don't have it highlighted, Or if you don't have anything in at all, make sure you click this first and then type the number in. All right, so we have 88 for this one. So this side has to be 88. All right, so the longest thing on that one is going through and doing Pythagorean theorem, but it's still not too terribly horrible. So let's go ahead and, whoop. Why is it not letting me click start here? Uh-oh. There we go. It was just frozen for a second there. Okay. So let's go through, and we have our perpendicular bisectors of the sides are SV. We have SV and TV and UV. So these are our perpendicular bisectors. So right away, I know that a bisector means that it's cutting these in half. So I'm going to go through and I'm going to mark. I already know this is happening because of the perpendicular bisector. And then this is the incenter. So I also know that all of these lengths are the same. Sorry, not incenter, it's the circumcenter. So all these lengths are the same. From the circumcenter to the vertice, these are all the same. All right, so let's go ahead and start filling it in with actual given information here. So UV, which is this distance here, is 54. I know this one's 54. I've already marked all those other ones red because, oh, nope. See, I'm mixing my theorems up here. The red ones are not congruent. The blue ones are congruent. Let's go back to pen. So I know this one's 54. PS, so this one out here is 82. And then RV, which is this length here, is 90. So this is the one that we can take around. If I know that this one's 90, then QV is 90 and PV is also 90. Okay, so we can start working out what we need to for the rest. So PU, so we want PU here. So this is going to require that Pythagorean theorem. I have two sides of a right triangle. I need the third side. So remember, the sides A and B are the ones that create this 90. So I'm going to say 54 squared plus B squared equals 90 squared. 90 is across from the right triangle, so the other two have to square and add together to be this one squared. All right, we are going to grab the calculator. We're going to do 54 squared equals, so we get 2916 plus B squared equals 90 squared. Okay. 8100. We're going to subtract from both sides because, again, we're always trying to get that variable by itself. Any number minus itself cancels. So it doesn't matter how big the number gets. If I'm taking a number and I'm subtracting it from itself, it's going to go away. We bring down B squared and we're going to subtract. So we have 8100. It's already in there, so I can just hit minus. It'll keep going for me. 29. So 2916 equals, when I get 54, whoops, 51. Trying to remember the number as I looked across the screen here. 5,184. I don't want B squared. I want to take the square root. So this B is going to equal, as long as it's highlighted here, I can just click the square root button and then equals. So 72. So this is PU right here. So we were just looking at this one. So remember that was our B. So PU is 72. All right. PR, so we want PR. So we want this whole length here. I'm going to switch up to a kind of bright green. If I want this, I would help if I click my pencil tool. So I want this whole length here. So PR. I already know this half is 82. And I'm saying half, so I'm kind of giving it away here. Remember, this was a bisector, so this is the midpoint. Half is 82. Well, this other half also has to be 82. So we just want to add these two together. So we get 4 and we get 16 because we were adding. So we get 164. 164. And then QV. So QV, I'm pretty sure we already have marked here. Yep, we do. Because remember, we were given this one as 90. So we know that all these other blue lines are also 90 because remember, the circumcenter means that all of these from vertice to the center here are congruent. And that's because of the perpendicular bisectors. All right, check that. Yay, we got a point. All right, next, clear. Okay, so we are given, and I'll make these red again. So we're given that XW, okay, XW and YW, CW. See, these are all perpendicular bisectors. And we have a circumcenter, which tells us that these lines here are all congruent, all the same distance or equidistant from the circumcenter and the vertice. So we know the blue lines are all congruent. Remember, the red lines are not congruent. They're just perpendicular bisector. But perpendicular bisector tells us that it cuts these in half. So that one word is quite a lot of information. All right. So let's go ahead and put some given information in here. So we have WY. So this one here is 42. Sorry, that looks like a 9. 42. And DE, so this whole length is 106. And then FW, so this length here, let's see if I can write it sideways here, is 70. So 70 is here, the 42 belongs to this one. So if this one is 70, it's on a blue line, all the other blue lines are also 70. Remember, red are not congruent, but the blue ones, when because I'm using that color, those ones are congruent. All right, so let's go ahead and figure out what it is they want. So EY, so they want EY. So right away, we're going to use Pythagorean theorem. Because here we have a right triangle, we have 42, we have 70, but we don't have EY. So we need to go through and plug it in. So remember, we have the sides that make the right angle here. So I'm just labeling this one A, and it doesn't matter if it's A or B. As long as it's a side that makes this 90 degree here, that's what A and B are. 70 is the one that has to be outside because that's across from the right angle. All right, so I have A squared plus, go ahead and do the math here. So we have 42 squared, and that gets me 1,764 equals, oh, we'll see if I can get this on here because this is going to be a big number, squared. Oh, it's not too terribly big. So 4,900, and then we're going to subtract this 1,764 from both sides. Oop, 4 didn't come out very well. We bring down A squared. Any number minus itself cancels. And this is going to equal, let's go back to our calculator. We're going to subtract 1,764, and we get 3,136. And our last step, remember, I don't want to know what A squared is. I want to know just A. So I'm going to take the square root. And we get, as long as it's highlighted, and click here and then equals. So I get 56. So this is the distance of this one here. So EY is 56. Go back. EY is 56. All right, so DW, which we already wrote in. It's one of our blue lines, and we know all the blue lines are 70. It's kind of the nice thing about just filling in some given information, makes it a little easier to go through and just fill in the answers at the end here. All right, so ZE, and I apologize, I wrote this in the same color here, so I'm gonna change this one. So this was our given information here. So we had this one, which was 106. Okay. Dang it. Can't seem to write the same line. All right, so 106 for DE, and they want just this distance here. So remember, this point is the midpoint, which means it's half. We just take half, so we have 106 divided by 2, and we get 53. So we just put 53 in here, and we're going to check. Yay, we get 2 more points. All right, we're going to clear. Next, we have 1 more. Okay, so let's go ahead and mark our pieces here. So we have Kn, whoops, keep doing that, Kn, Ln, and Mn. So these are our perpendicular bisectors. Remember, perpendicular is shown with the right angle. Bisector means it cuts all of these in half. Okay, that was one line, one tick mark there. Just kind of came off ugly. And then we also have this perpendicular bisector where they intersect, which is our circumcenter, which means that all these distances from the vertices are equidistant. They're the same. All right, so now we've got some of this marked. Let's go ahead and put our given information in here. So Ln is 22. JK, so this out here, so just the half information is 82. And then GN, so this line here is 122. So if this one's 122, it's, remember the blue lines are the ones that I keep drawing as congruent. So I already know all of these are 122. Okay, so let's go through and start figuring out what is it. Let's see, I'll do dark green here. So what is it that they want us to figure out? HN is the first one. So HN, oh, look at that. We already filled in HN. So 122. All right, LJ, so this one here. So it's a missing side of a right triangle. So we get to go through and do some Pythagorean theorem. So I have A and B and C. So remember, C is the one that's very specific. It has to be across from the 90. Even though you don't see the 90-degree mark, if one's on, if it's on one side of the line, it's also on the other side of the line. It is actually one of the properties of perpendicular bisectors. Both sides will be 90 degrees. Again, that goes back to a line is 180 degrees if you divide it, or if you take 90 away, you get 90 for the other side also. All right, so I have 22 squared plus b squared equals 122 squared. So that's going to be kind of a big number there. So let's go 22 squared equals, help if I click my pencil, 484 plus b squared equals, go back and we go 122 squared equals, all right, so that's a much bigger number, 14,884. We're going to subtract 484 from both sides. Whoop. And so any number minus itself cancels. B squared comes down, and that equals, and let's see, we get minus 484. Could probably do that without a calculator, but easy enough to just type it in. So we end up with 14,400. Remember, I don't want b squared. I want to know what just b is. So, and come back over here. As long as it's highlighted, I can click square root and equals. So we get b equals 120. All right, so we get 120. And that's for LJ. Remember, that's what we were looking at. All right, so the last one here is GJ. So GJ is the whole thing. Remember, this is the midpoint. So that means that 82 is half. So I'm just going to go over to my calculator here. If I know 82 is half, do 82 plus 82 or times 2. And that will give me 164. Check. We're good to go. We finished another one. Yay.